Find the location and nature of the critical points and the location of the point of inflection for the following function. Alright. Now to find where the critical points are, whether it's a maximum point or a minimum point, you know that the gradient will be 0. That means if you draw a tangent to the curve at the maximum point or at the minimum point, it will be horizontal, so the gradient is 0. So we can find out where that is by finding the gradient function and equating it to 0 and solve. So the gradient function will differentiate. dy by dx is equal to 3 times 2. You know, you multiply by the power. 3 multiplied by 2 going to be 6 x to the, and then the whole power minus 1 gives you the new power. 3 minus 1 is 2 minus 2 times 3 is 6. X to the 2 minus 1 is 1. But you don't really need to put the 1 there. Minus. This is really x to the 1. So when you multiply the power, 1 by 12, you get back 12. X to the, you know, is whole power minus 1. 1 minus 1 is 0. So what you get is really 12x to the 0. But 12x to the 0 is 1. So it's like 12 times 1. Yeah. And then 36. Well, 36 means 36 by 1. You remember that? But when you times 1, it's the same as multiplying by x to the 0. When you multiply 0 times 36, you multiply the power. So you say plus 0 times 36 x to the, then the old power minus 1 gives you the new power, x to the negative 1. Alright? So, what you have for dy by dx, dy by dx, what does it amount to? It's 6x squared minus 6x minus 12. 0 times all of this gives us 0. Alright, now this is a gradient function. And at the critical point it is equal to 0. Alright? So we're going to solve 6x squared minus 6x minus 12 equals 0. Well, if we divide everything by 6, we have x squared minus x minus 2 equals 0 over 6 is 0. Alright, we want to solve this. Can we solve it by factorization? It's a quadratic equation. If you have 1 times negative 2 is negative 2, we want to find two numbers that multiply to give negative 2 and add to give negative 1. Those numbers would be, there's a 1 and there's a 2. 1 and negative 2. Alright. So, at one end we have x squared, at the other end we have minus 2. Then we split the negative x into plus x minus 2x. Good. Remember how to solve your quadratic equation by factorization. Then we factorize the x squared plus x, we get x outside the bracket, x plus 1 inside the bracket. We're going to factorize 2x minus 2. As well, we should get the same thing inside the bracket. So outside the bracket we have negative 2. Negative 2 into negative 2x goes positive x. Negative 2 into negative 2 will go positive 1 plus 1 equals 0. Then the x plus 1 is a common factor here. So you have x plus 1, open bracket, x plus 1 into x, x plus 1 is x plus 1 into negative 2x plus 1 is negative 2 equals 0. So it's either x plus 1 equals 0 or x minus 2 is 0, or both. So if x plus 1 is 0, then x is negative 1. And if x minus 2 is 0, x is positive 2. So we have the locations in terms of x. Let us find the coordinates since we want the location. When x is equal to negative 1, what is y equal to? Let us see. We have x is equal to negative 1. Let's use our calculator here. So here now, negative 1 cube is negative 1. So 2 by negative 1 is going to be negative 2 minus 3 times x squared. Negative 1 squared is positive 1. 3 by 1 is 3. So it's 3. Then minus 12 by negative 1 will be minus negative 12, same as plus 12. Plus 36 equal. Y is 43. So when x is negative 1, y equals 43. When x is equal to 2, what is y? Let's see now. Let's get back our calculator. So here, when x is 2, 2 2s for 4 2 is 8. 2 cube is 8, 8 2 16, so it's 16 minus 2 2s 4, 4 3 is 12, is minus 12 minus 12 2 is 24, 24 plus 36 equal 16. So when x is 2, y is 16. So the critical points are at negative 143 and at 216. Okay. Now, we want to find out the nature of the critical points. Here, what we're going to have to do is differentiate what we got when we differentiated dy by dx. Right? So you do a second derivative. So d squared y by dx squared is equal to, have 6x squared when you differentiate that, 2 6 12, x is going to be 12x, and then minus 6, and when you differentiate negative 12 you get 0, so it's minus 6 what you have after this. Alright, now you know that we're going to substitute the value of x here. When you work it out, if we get a positive number, you know that's the minimum value, right? Because if you have a zero gradient, tangent here is 0, and you move to the right, it's going to swing upwards to the positive. Or if you're standing at the bottom of this valley and you start walking, you will be going upwards. You'll have to climb a hill. So it's a positive, then it's a minimum, right? If it is a negative, it's a maximum, because the tangent is 0 at the critical point, and when you move to the right, the tangent will swing downwards, negative, so negative. Or if you're standing on the top of this hill and you walk to the right, you'll be going downhill. You'll have to climb downhill. So negative is a maximum value. Now, when x is equal to negative 1, 12 by negative 1 minus 6. You can see it's a negative. It's going to be a negative value. So this point, being a negative, is a maximum point. The negative 143 is a maximum point. And at x is equal to 2, you have 12 by 2 minus 6. 12 2 is 24. 24 minus 6 is a positive. It's a positive value. Right? So, this is going to be a minimum point. So the critical points are negative 143 maximum, Let me just write it up here. Negative 143 is a maximum point, and 216, which is a minimum point. 216 is a minimum point. Now we want the point of inflection. So to get the point of inflection, you equate the second derivative to 0. 12x minus 6 is equal to 0, and then you find out what x is. 12x is going to be equal to 6, so x is 6 over 12, which is 0.5. So x is 0.5 at the point of inflection. What is y? Alright, so we want to find out what y is when x is half. Now, when x is a half, half cube is going to be 1/8. And then 2 over 8 is a quarter. In other words, 0.5 by 0.5 by 0.5, that's half cube. And times 2, you get 0.25, a quarter, right? Minus 3 times half squared is a quarter. Right? 3 times 0.25 is a quarter. Minus 12 by half is going to be 6. Then you say plus 36 equal 29.5. Alright? So, that's what you get there. A quarter minus 3 by a quarter. Alright? Minus 12 by half, which is 6, plus 36, 29.5. So, y is 29.5. So the point of inflection is half, 29.5. So, inflection is at 0.5, 29.5. Let us plot this graph, or sketch this graph and see what would it look like. Alright, if we have an x-axis and a y-axis here, then we would have negative 143, going to be a maximum point. If this is negative 1, this is 43 up here, going to have a maximum point. 2 to be here, and 16, let's say 16 is up here. We're going to have a minimum point. And I expect the graph to look something like this. There will be a point of inflection at half, 29.5. So right there, the point of inflection. Anyway, let us use our graph plotter to plot this graph and see what it looks like. Right, we have GeoGebra graph plotter. Let me type in the function 2x cubed minus 3x squared. I have 2. Alright, so let's type in the function 2x cubed minus 3x squared. Alright, 2x cubed, 2x to the power of 3 minus 3x to the power of 2 minus 12x plus 36 minus 12x plus 36. Alright, we're seeing part of the graph. Let me just kind of fix it up here. Make it a thicker line. I want to show the label. We have 2x cubed minus 3x squared minus 12x plus 36. Alright, we have to zoom out to see this graph. Alright. Now, let's zoom in right here and see where it is. It's supposed to be at negative 143. So, where's negative 1? Let me go up. Just to make sure. Alright, this line is negative 1. Let's follow this line and go up. Alright, negative 143, we can see it. It's at negative 143. And it is a maximum point. Good. The other one is 216, minimum point. So let's find out where 216 is the minimum point. Scroll and scroll and scroll. Alright, go to 16. This line should be lined up with 2. 216. This should be at 2. Right, here's the 2. Let's line up with the 2. Okay, good. And the point of inflection is at half 29 and a half. Let's see. So we're 29 and a half. Half 29 and a half. So it's half 29.5. So we have 12x minus 6, which is a positive 6 over 12 half, and then 29 and a half, 29.5. Now let's look back at our calculator, make sure everything is okay, and our function as well. So we have 2 times half, x is half, half cube is 1/8, 2 over 8 is a quarter, so it's 0.25 minus 3 times, we have 0.25, which is half squared, 0.5 squared, minus 12 by half, which is 6 plus 36, right? We have 29.5, good. So, 29.5 half. So, it's half 29 and a half. Let's see if we can find it. Where's 29 and a half? Let's zoom out a bit. 28, 29, 29.5. 29.5 is alright, 29.5 is right here. Now this line that I'm following, it should take us down to half. It's, if you can zoom out a bit to move a bit faster down, because I want to make sure that this is x equal half, alright? Don't want to lose this line. Alright, so is it half? Ah, good. Yeah, so it is half, 29 and a half. So that's where the point of inflection is. So now, let's zoom out, and I want to put a tangent line to this curve. Let's do that. Okay. Let me just make some adjustment to the tangent and make the color blue and make it thick. Now, as I move the tangent to the right, you see it has a positive gradient. And as I go towards the maximum point, right at the maximum point, it is horizontal. It's hard to get it horizontal here. But then, horizontal, then as I move to the right, it becomes negative, it swings downwards. So the second derivative had a negative value there. Let's see what happened at the minimum point. Alright, first of all, at the point of inflection, let's see what happened there. The point of inflection. Notice now. You see the tangent swinging down. Then as I move to the right, it swings. Let's move to the right, it swings down, 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 down. But slower and slower. Then it seems to stop at some point. Then it starts swinging upwards. Alright? So, let's do that again after zooming in. Zoom into the curve. As I move to the right, the tangents. Alright, let me move to the right. It goes to a negative, more and more negative gradient. Swings down, and the swinging stops, and it starts to swing back up. The point at which it stopped for a moment is the point of inflection, right? Which we found to have been half, 29 and a half. And then, after that, as we move the tangent further to the right and observe what happens at the minimum point. Let's kind of zoom in at the minimum point. To see what happens there. At the minimum point now, it becomes more and more, it becomes positive. It still has a negative. To the left of the minimum point, the gradient is, the tangent has a negative gradient. Right? At the minimum point, it's horizontal, zero gradient. And then go to the right, it's positive. It swings upwards. Positive. So, the second derivative, when you substitute x in it, it has a positive value. Alright? So the maximum point, it swings from positive to negative. So that's what turning point. The minimum point, the gradient swings from negative to positive. It's also a turning point. The gradient turns. Alright? The point of inflection would not be a turning point because it did not turn from positive to negative. At the point of inflection, it's negative, more and more negative, but At some point it stops, swing back up, or it is still negative. Alright? Negative gradient. So it's less negative after it passes the point of inflection. It doesn't turn. But at the maximum point, it turns from positive to negative. At the minimum point, it turns from negative to positive. So those are turning points. Alright? Critical. Those are two critical points that we have here. Alright, so that will be it for now. I'll see you in the next video.